Okay, in this lesson we're going to be constructing some things, and we're going to be looking at a couple of special segments in triangles. So at the beginning here you're going to need your compass, and we're going to use the compass to construct the perpendicular bisectors of the three sides of the triangle. So it's a little tedious at first, but you will get used to it once you do these things. So I'm going to make the perpendicular bisector of all three sides. So I'll start with this side. I'll make an arc. Then I'll come over to the other end. Make the same size arc. And I'll draw my line segment here. Make it long, because we're going to see if these things intersect on all three sides. So now I'll do this side over here. Make an arc, come over here, make an arc, and draw that one. Now see, it starts to get a little confusing because you got to figure out which segment you're dealing with, where your intersection points are. So you got to kind of focus on that. Boom. All right. Now let me do the bottom side. So you want to make sure you're more than halfway. Make an arc. I got to pay attention to which arc is which. Right there. And then I draw that line. What you'll see, it will not be perfect, but all three of those segments intersect in the same spot. You know, two lines that are not parallel will always intersect, but it's kind of special when you can get three of them to do that. So what we say, we're going to come up with a name of these three perpendicular bisectors when we get there. Focus. All right, so when three or more lines intersect in a single point, we call that concurrent. They are concurrent. They all intersect in a single point. And the point of intersection is called the point of concurrency. We're going to be looking at two of them today, and then we're going to be adding two more in the next couple of lessons. Okay, so we're going to talk about the name of this guy. Actually, let me skip back up there. Okay, so this point of concurrency of the intersection of the three perpendicular bisectors, that's called the circumcenter. Okay, that's the first one we're doing, the circumcenter. So the next one, we're going to construct the angle bisector. So you just learned how to bisect an angle like yesterday. So I'm going to bisect these angles. To do that, I make an arc. And then I like to open up my compass to get my intersection arcs way out here, so it's not so cluttery. And you make equal arcs. Draw your line. That bisects that angle in the triangle. Again, it won't be perfect because your compass isn't perfect. There you go. We're going to do two more. Bisect angle A. I draw an arc. And then I come out here. And I make equal arcs. And there's my second one. I come over to C and do the same thing. And if we do this fairly accurately, you're going to see that the three angle bisectors are going to be concurrent. So there's an arc. There's an arc. And it goes right through there. So this is another point of concurrency that we're going to talk about. That one is the intersection of the three angle bisectors. So this has a name. It's called the incenter. So on the next page, we're going to kind of fill in the blanks here and do more formal definitions. Okay. So filling in the blanks. The first one we said was the circumcenter. That's the intersection of the perpendicular bisectors of each side of a triangle. It's also the center of a circle that circumscribes the triangle. That means the triangle is inside the circle. The circle is around it, and it hits all three vertices. The circumcenter is equidistant from the vertices of the triangle. That's this first picture here. This point is the circumcenter because it's the intersection of the three perpendicular bisectors, and you see the circle is all around and it hits all three vertices of the triangle. The incenter is the second one. It's the intersection of the angle bisectors. That's this picture. It is the center of a circle that is inscribed in the triangle. The incenter is equidistant from the sides of the triangle. So this little circle here, if you dropped a perpendicular line to each one of these sides, that would all be the same distance. So it hits each side in one spot, one point. Okay, so the rest of this is practice, and we're going to be doing that part in class as much as we can because, not everybody's in class. So have your compass ready and your ruler ready, and we'll be going through the first one and the other two in class.